Good morning, welcome to new lecture. Today I will talk about influence line. Let's first define the influence line, see what is the influence line. What is the influence line? An influence line represents a variation of internal forces These internal forces, you know, we can have axial force, shear force, or bending moment. At a specific point of beam, and or at specific member of truss as forces travel along the structure. What does that mean? Let's explain in simple words. For example, we have one simply supported beam. There is a load, it is for example concentrated load. The magnitude of the load is P. For example, influence line of reaction A means if we put P in different location in this beam, AB beam, for example, I can put P directly in support A, or I can put here, or I can put here, or I can put here. So load can travel, can move from x is equal to 0, it means this point, I might measure x here, x is equal to 0 up to x is equal to L. I can put P in any location, like for example this is bridge and the load P is like one car. Where I should put that car, I have the maximum reaction at point or support A. That we can find using influence line. Or for example, instead of reaction at point A, we have one point, like point C here. For example, the length of this beam, it is 20 feet, and the point C location, it is 3 feet. Again, I have one concentrated load like P. This P, it will move from A to B. In any location I can put. Where I should put P, I have maximum moment at point C. I need to draw the influence line for moment at point C. Where I should put the load P, I have the maximum shear force at point C. I should draw influence line for shear force at point C. So, in order to find the location of the traveling load on one bridge, for example, it is beam or truss, I should be able to draw influence line. Drawing influence line will help me, and I will able to find the location of that load. Where I should put the load, I end up with maximum reaction, maximum shear force, maximum bending moment, or in truss, you know, we have only axial force. In truss member, we don't have shear force or we don't have bending moment. Where I should put that load, I end up with maximum tension force or compression force. So, we draw influence line for traveling load. In the structure, we have different loads. We have dead load, like self-weight of material, roof, beam, column, slab. These are dead load. The location of load will not change. But we have live load, for example, the location of the car traveling on the bridge, or the people, they are moving around. So live load can move, can travel, but dead load will not travel. So we will draw influence line always for live load. Let's say add here once the influence line is drawn, the location of the live load which will cause the greatest influence on the structure can be found. So we can find where we should put this live load. In that case, we have critical situation. We have maximum bending moment. We have maximum shear or maximum support reaction. Therefore, influence lines are important in the design of structure. Where the loads travel along the span. If load they don't move, in that case we don't need to draw influence line. So let's look at the difference between influence line and moment and shear diagram, internal forces diagram. Let's say define each one more time. In that case you can compare and see what is the difference. Influence line influence lines represent the effect of a moving load only at a specific point on a member. Whereas shear and moment diagrams represent the effect of fixed loads. So here loads, they will not move. Fixed loads at all points, and it is at all points, not only at a specific point, at all points along the member. So now you can see what is the difference between influence line and shear and moment diagram. Let's look at one example, very simple example, and find the influence line for this example. Assume we have one cantilever beam support A, free end B, and point C, and 10 meter cantilever beam. We want to find the influence line for reaction at point A. It means if we have one load like P and it travels from A to B, what is the variation in the support reaction at point A? Assume the magnitude of this load instead of P, it is unit 1. For example, 1 pound, 1 Newton, it is unit load. If I put this load at point A, okay, at support A, what will be the reaction? Entire load will transfer here, so the reaction will be 1. If I put this load at point C at midspan, what will be the reaction? If I put the load at midspan, again reaction at point A is equal to 1. If I put at point B, at free end, this load, I'm changing the location. First I put at A, then I put at C, now I'm putting here. If I put at B, what is the support reaction at A? Again it is 1. So support reaction will not varies with the location of moving or traveling load. So the influence line will be one rectangular. Now, if the magnitude of load instead of 1, if it is P, and I put at point C, what is the support reaction at A? P, the magnitude multiply the height of influence line underneath of that, it is 1. P times 1 will be P, so the support reaction will be P. And because in any location I put this force, support reaction is positive, so I will put positive over there. Now let's look at the influence line. Moment at point A. So this is reaction at A, now moment at A. If I put load 1 at point B, what is the moment at point A? it will be 1 times 10. So if I put load 1 at point B, the moment at support A will be 10, because 1 times 10 will be 10, and it will be negative. So here will be 10. If I put at point C the same load at point C, assume the magnitude of load it is 1. If I put at point C, what is the moment at point A? It will be 1 times 5, it will be 5. So here it will be 5. Now, if I put load at support A, what is the moment at support A? It will be 0, because there is no distance between load and support. It will be 0. If I attach these points together, you can put in different location. You will have influence line for moment at point A. Now, instead of 1, if you have load, for example, P. If you put P here, P times 10, moment at A it is 10. 10P, sorry, moment at A will be 10P. Now, P times the height underneath of that influence line, it is 10. So, you will get 10. If you put P at point C, what is the moment here? P times 5. If you put in influence line P times the height underneath of that, again will give us what? 5 times P, 5P. If you put at support A, what is the moment? It is 0 here. Height underneath of that, it is 0, so we will get 0. If I want to draw shear influence line at point C, for example, if I put load here, any load, for example 1, shear force in free body diagram, if I cut here, it is 0. From here to here, in any location I put that load, it is 0. From here to here, any location I put that 1, the shear force will be 1. So this will be the influence line for shear force at point C. Let's look at another example. Simply supported beam. See if we have simply supported beam, what are the influence lines for shear force, for support traction, for bending moment at a specific location. For example, we have this simply supported beam. The length is L, A, B, point C, and the location of point C, from here it is A, from here it is B. I want to draw influence line for reaction A here. What is the influence line for reaction A? I will put unit load in one location like X, distance from support A. Now, because X will vary from 0 to L, X can be 0, can be L over 2, so X will vary from 0 to L. Reaction at point A will be 1, if I take moment respect to B, 1 times L minus X minus RA times L is equal to 0. From here I can write Ra is equal to 1 minus x over L. So, this will be the reaction for point A if I put the unit load at location of x. Now, x varies from 0 to L, so I can draw this function Ra. If x is equal to 0, what is Ra? 0, it will be 1. If x is equal to L over 2, that will be half. If x is equal to L, you will get 0. So this will be the influence line for reaction at A. So influence line for reaction A, equation is 1 minus x over L. Let's look at the influence line for reaction B. Now I should put unit load at x distance and find the reaction B. If I do that, I will have Rb times L minus 1 times x is equal to 0, so Rb will be equal to x over L. Now, x is equal to 0, Rb is 0, x is equal to L, Rb will be 1. This is influence line for reaction B, influence line for reaction A. So we can find function. For x we can plug different numbers. In that range that function is valid, and find the magnitude and attach together. So we will draw influence line. Now let's look at the influence line for shear at point C. Influence line for shear at point C. So if I draw free body diagram, this is A, VC, this is RA, which is 1 minus x over L. Now, if the load is x varies from 0 to A, so x varies from 0 to A means the unit load is here. What is the VC function? VC will be equal to 1 minus x over L, summation of force in vertical direction is equal to 0. VC is equal to 1 minus x over L minus 1. That will be equal to negative x over L. So for shear force VC, if I put x is equal to the 0, I will get 0. If I put x is equal to A, I will get negative A over L. But how about if x varies from A to B? So if x varies from A to not B, x one time varies from 0 to A, another time from x will varies from A to A plus B or L. X varies from A to A plus B or L. In that case, the VC will be equal to, I can draw free body diagram even from this side if you want, or let's continue from one side. That will be VC will be 1 minus RB, which is equal to RA. That will be equal to 1 minus x over L. So if I draw free body diagram this time, this is 1 minus x over L. Here you have A, this is your X, and this is your VC at cut point. So a unit load now, it is here. Unit load is here, it is 1. So this time, if I look at the other side, let's draw free body diagram from it. Even other side, that maybe it is easier to visualize it. This will be RB, this will be VC, unit load is here. So summation of forces in vertical direction, it will be VC is equal to 1 minus RB. 1 minus RB, because summation of all forces is equal to the 1, will be equal to RA. That will be 1 minus X over L. So from A to L. Now, if you plug X is equal to A, X is equal to A, here you will get 1 minus A over L. That will be L minus A over L. That will be equal to B over L. So here, this side you will get B over L. If your X is equal to L, X is equal to L, L and L they will cancel, you will reach to the 0, and this will be influence line for shear at point C. Let's look at the influence line for moment at point C. Influence line for moment at point C, again we will draw free body diagram. Here we have RA, again X between 0 to A one time, unit load you are putting here, and the distance it is X, and here it is point C. I want to find MC. So MC will be RA times from here to here, it is a RA times A minus 1 times A minus X. From here, MC will be equal to RA, you will plug 1 minus X over L, A minus A plus X. So you can simplify this. From here you can write MC is equal to X minus A X over L. Yes. And so here, if I show influence line, let's I remove this because I don't need this anymore. Influence line for moment at point C. Okay, X is equal to 0. M is 0. X is equal to the A will be A minus A squared over L. That will be equal to L, LA minus A squared. That will be L, A, L minus A. That will be equal to A. L minus A will be B over L. So the moment here will be AB over L. Let's look at two. Once X is between A to L, or I can measure from this side even. I can tell it is from 0 to B. You can do that too. Any direction you can measure it. Free body diagram, RB, 1, unit load 1, you are putting here unit load 1, and you find MC, you have RB, so MC will be RB times B. From here to here it is B minus X minus A times 1 X minus A, the distance of this load from left support, times 1. So X minus A will be this distance, times 1 will be moment. So from here MC will be equal to B X over L plus A minus X. Again, if you put X is equal to A, X is equal to A will be AB over L plus A minus A. So these two cancel, AB over L. If you put X is equal to the L, you will see if you put X is equal to L, this will be B plus A minus L. A plus B it is L, L and L, it will be 0. It comes to the 0. So this will be influence line at point C. So influence line at point C for moment. Influence line at point C for moment. Influence line at point C for shear force. And influence line for reaction A, which I remove it because I didn't have enough space, but you saw that. Influence line for support, reaction at support A, influence line for reaction at support B, influence line for moment at point C, influence line for shear at point C. I think for today only I introduced the influence line, it is enough. Next session I will teach you another method, and I will look at the distributed load as well to see how we will deal with distributed load, and then I will solve several examples, a lot of examples for beam and trusses. Thank you so much for watching this lecture. See you next session. Bye.